Alright, so we're going to begin section 12.1, which is vector value functions. So a vector function capital F of t with the vector hat over that f is a function of the form. So in your book, these are going to be boldface. Is a function of the form f of t equals lowercase f sub 1, the vector lowercase f sub 1 of t, lowercase f sub 2 of t, and then lowercase f sub 3 of t. Those are the components of our vector, where the component functions f1 of t, f2 of t, and f3 of t are scalar functions or real value functions, whichever one you want to call it, or real valued functions. And that's just the type of functions that you all have been accustomed to seeing for years. And t is the independent variable, and t is the independent variable. The parametric equations of f of t are x equals f sub 1 of t, y equals f sub 2 of t, and z equals f sub 3 of t. A function, or a vector function, a vector function f of t is often used to represent a curve C in space or in the plane. For each value of t, f of t is a position vector. As t varies, f of t traces out the curve C. All right, so that's the extent of the official lecture notes. And now we're just going to spend the rest of 12.1 just doing examples. So we're going to start in your textbook on page 759. We're going to do number 14, which says in exercises 13 through 26, sketch the curve traced out by the vector value function. Indicate the direction in which the curve is traced out. All right, so for these exercises, I'm not so concerned with you all's ability to sketch these things, more so with your ability to identify them. So when I'll talk about that, and I actually will go through and I'll sketch some of them, and then some of them I'll just identify without sketching. So this is one of those times that I'm going to first write it the way the textbook has the problem written, but you all know that I normally don't use I, J, and K. I tend to use the pointed brackets, and this is one of those times in particular I think it's beneficial to use the pointed brackets because it kind of makes it a little more clear what's going on. So they give us f of t equals cosine of pi t k, cosine of pi t k, and they tell us t varies between -1 and 1/3. All right, so this is the way it's written in the textbook. Now, I don't tend to write my vectors that way, so I prefer this. This is 0, 0, cosine of pi t. Now, in particular for these problems, I think it's a lot more useful to write it that way because now I can see x, y, z, which was what we're accustomed to seeing coordinates. So this tells me x equals 0, y equals 0, and z equals cosine of pi t, where, of course, we're still abiding by this restriction on t. Now, as soon as I have this, okay, I know x is always 0, y is always 0, which when I look at this, it may not be apparent that this is something that's just on the z-axis to you, but here it will certainly be apparent because x is 0, y is 0. You might be misled to think that x and y can vary because they don't appear here, but that is something different, and I've discussed that. We have talked about that before we were talking about vector value functions. But now with the vector value function, the fact that x and y don't appear here, z doesn't appear here either, doesn't say that they're free variables. They're restricted to being 0 here. So that's why it may be beneficial to write it that way, because this is actually a vector. So now, in looking at this, I know it's going to remain on the z-axis. And if it's stuck on the z-axis, it has to be a line in some shape, form, or fashion, or a line segment or something of that nature, which may not be readily apparent here. But that's what I said, that I'm more concerned about your ability to identify versus your ability to sketch. And when you see this, or this one, whichever one, you should be able to identify, okay, this is going to be a line segment in some shape, form, or fashion, or a line or array or something like that. I'm stuck on the z-axis. So now, what does this look like? So let's sketch a set of coordinate axes, and then we'll sketch this. And remember, I'm not highly concerned with your sketching of these. I'm more so concerned with your identifying. So our set of coordinate axes. All right, so now in order to figure out what this thing looks like and also its direction of travel, which is another thing that they asked us for, we're going to take some values for t in this interval, and we're just going to plot those points and give an idea of what's going on here. So at t equals, let's start at the smallest value, t equals -1, because this is going to dictate which direction our curve, whatever our curve is, going to travel. So I tend to start at the left and move to the right. So at t equals -1, so when we put in t equals -1 here, we get cosine of -5, which is the same as cosine of pi. And that's going to give us, actually make sure I cut this. That's going to give, so cosine of pi, which is going to give us that z equals -1. I was making sure I copied the problem down correctly. So now at t equals 0, at t equals 0, we put that in, we get cosine of z equals cosine of 0. So that tells us z is going to be equal to 1. And then and I'm just picking arbitrary values in here. I mean, I pick stuff that's easy, of course, and then paying attention that I have cosine of pi times t. I don't want to pick anything like whatever, some odd value like -3/7 or something like that, where I can't figure out what the cosine of -3/7 pi is. So then t equals 1/3. And that will give us cosine of pi over 3, which gives us the z equals 1/2. All right, so if we start at, this is the beginning, at t equals -1, we are going to be at z equals -1, which is, we'll say down here. So this is 0, 0, -1. And then at t equals 0, I'm going to be at z equals 1. So I'm moving in the positive direction here, which is going to help me indicate arrows when I sketch my little line segment. So at t equals 0, z is equal, so times 0, z is going to be at 1. So z is going to be up here at, what did I say, 0, 0, 1. So that means my line segment is moving from here to here. So my arrows are going up in that direction. Then at t equals 1/3, so at the very end, z will be at 1/2. So I've gone up all the way to 1, but now my z is going to be at 1/2. So it's going to come back down to here. After it moves all the way up to the top, it's going to come back down. And in order to try not to confuse things, I'm going to put my other arrows kind of off of the line itself. So it's going to go up, it's going to come back down, and it's going to stop at the point 0, 0, 1/2. So if we were to just sketch the line segment with no arrows, it would just be a line segment that went from -1 to 1. But the arrows are actually trying to indicate what I was specifying earlier, where you trace out the curve. So it goes up and then it comes back down. Now, it doesn't look any different than if it went all the way up, but the arrows are actually important in a vector value function. So it doesn't suffice to just leave those off. All right, so next, let's look at number 16. And in looking at these problems, what you want to do initially is try to see if you can identify or get an idea about what it's going to look like without sketching it, and then you can go and try to sketch it after that. So number 16, same directions as number 14. So we're supposed to sketch it. And they give us, and remember, I'm going to write these using the pointed brackets. F of t equals 2t, comma, -3t, comma, 1. All right, so now we've seen something like this on multiple occasions. So this is x naught plus at, y naught plus bt, and z naught plus ct. So we know what this is. This is an equation of a line. So that's why I said work on trying to identify and just looking. It's a lot easier if you kind of look at what the parametric equations are. So this is just a vector equation of a line, and you all are all familiar with identifying what a parallel vector is and a point on the line is from those equations. So we can automatically do that. Containing P naught, what is a point on the line? Remember, it's x naught plus at, so x naught is 0. Y naught plus bt, so y naught is 0. And z naught plus ct, so z naught is 1. and parallel to the vector L, which we can also pull out of here fairly easily. Parallel to L, which our A is 2, our B is -3, and our C is 0 because there's no T there. All right, so now we've identified what this thing is just from our knowledge of equations of lines, but now I actually will go through and sketch this. But remember, the sketching is not important for you all to be able to do with these points. Some of these sketches are not, they're kind of difficult to visualize how to properly sketch them in 3 dimensions anyway. So my x-axis, my y-axis, my z-axis. The only thing without sketching is that we can't indicate a direction of travel in this line segment without really sketching. Well, we can say where it's moving from the two. So I could actually describe that and the way that you would do that without going through and doing a sketch. Now notice there's no restriction on t here. So t takes on any real values. So the way that you would do that is you just plug in 2 t values the same way I'm going to do for this picture, and you can tell which direction it's moving. You can say, okay, it's moving from, you can pick 2 points and say, okay, it's moving from this particular point to that particular point, and it continues to move in that direction. So you can still describe it in writing without necessarily having the picture. So now I want the vector 2, -3, 0, and the point 0, 0, 1. So let me start with 0, 0, 1, which is a little bit easier to work with. So, and then 2, -3, 0 says I'm going to go 2 in the x direction. I'm going to go back 3 in the y direction, and I'm not going to go up at all. Sorry, you couldn't see that very well. So I'm going to go 2 in the x direction. I'm going to go back 3 in the y direction, and then I'm not going to go up at all in the z direction according to my vector L. So I'm just sketching the vector L now. So L, let's say it looks something like that. Because that's my vector L, but that's not what they want us to sketch. They want us to sketch the line segment. So the line segment is going to go through this point, would be parallel to, the line, not the line segment. It's going to be parallel to L. So all right, and now normally when we draw a line, we would put arrows at both ends. You don't want to put arrows at both ends on here because we just want arrows going in the direction of travel. All right, so now I have to figure out, should the arrows be going this direction or should the arrows be going that direction? So you take any 2 values you want and plug them in there. So at t equals 0, what do I get? So at t equals 0, I get 0, 0, 1. I get that point right there. So 0, 0, 1. And then at t equals 1, for instance, and I plug that into here as well, I'm going to get the point 2, -3, 1. So now where would 2, -3, 1 be? So I would go out 2, I would go back 3, then I'll go up 1, which is going to be directly above that right there. So it would be like right here. So at t equals 0, I'm there. At t equals 1, I'm there, which tells me my arrows are moving in that direction for this entire line there. All right, so I'll stop this video here and then we'll continue in the next video doing some more examples from that section. What you can do in between is just look at exercises 13 through 26 and see if you can identify by writing out the vector in this form, see if you can come up with some kind of idea as to what the curve itself is.